In a post-apocalyptic world, zombies are roaming the earth, and the only way to survive is to wear a funny hat. You have three hats, a top hat, a fedora, and a sombrero. You know that zombies are attracted to the sombrero, but you don't know which of the other two hats is the zombie repellent hat. You can ask one question to figure out which hat to wear. What question would you ask, and why? Today we're going to take Llama 3.3 70B Instruct at a Q8 Quant through some initial speed tests, but more importantly I'm going to touch on a subject that we rarely touch on the channel, which is the PCIe traffic or bandwidth needed in a multi-GPU setup. This is not metrics that most home labbers are getting with their consumer level grade cards. So we are going to take my 6 A4500 cluster, which is enterprise level cards and can give us much more metrics, and I'm going to run it through a test and show you guys the bandwidth that is used on your PCIe bus in a multi-GPU setup. So let's go ahead and get this going. We're on my main cluster. Let's get rid of that 3090 that's not going to give us any metrics, and we're only going to use the 6 A4500. So let's go ahead and swap over to that. 2, 3, 4, 5. Go ahead and hit enter. This is basically patching this Kubernetes deployment for my LocalAI instance. You should go check out the LocalAI project. I run it on my Kubernetes cluster. You can run it anywhere if you're new to the channel. It basically is an OpenAI API compatible for running local LLMs, either on your machine or your lab, much like LM Studio or Llama. It also uses Llama CPP under the hood for most of what I use it for. Obviously, it can run other engines. Okay, so let's just take a look. We've got nothing but our 6A4500s over there. Let's make sure Llama 3.370B Instruct at a Q8. We're going to go ahead and name this A4500. Oh, I can't spell today. Llama 3.3. And we'll just do that. We're not running any serious tests today, but I just want to show you guys visually what is going on your PCIe bus in a multi-GPU setup. And we'll see just how Llama 3.3 70B reacts to our normal tests that we run on the channel. If you're new to the channel, welcome, and maybe you can go check out a few more videos about what I actually run and do in this lab quite a bit. But we're basically using a static 111 token prompt that asks the model to basically build us out a GitHub action that builds a Docker file, pushes the image up, and that's about it. But it basically gives us a repeated prompt that we can run over and over and over again and get performance metrics off of models and different hardware with. So I think we're going to run 10 tests this time, and we're going to go ahead and hit go. We're going to set this up to only watch the GPUs that we want it to. You guys are used to seeing this. This is Grafana and Prometheus. The metrics will lag behind just a little bit. Running down here, this is NVTop, but we're just going to use that to watch it load up. Now, something I don't normally show on the channel is the A4500s are enterprise class cards, which means that they actually spit out a lot more metrics. So this is actually the PCIe traffic coming in and out of each one of those cards. And you can see the model loading up here at, we had several gigabits per second going through the PCIe traffic. But once the model is loaded up and it actually starts to run, you're not going to see anywhere near that type of traffic. So we're going to go ahead and let this respond. And there it goes. Now this is going to take a while for that scale of 5 minutes over there to run off. and scale back down, but you guys got to see the loading time across the multi-GPUs along with the loading speeds of it hitting that. Now my models are stored on an NVMe storage, so it's fairly quick. It's fairly quick to load into memory on the GPUs itself. Now we're going to let it run through some of the tests here, just over and over, and you can see actually it's pretty verbose in its answer. Llama 3.3 doing a full explanation, giving you notes. First one back at about 5.78 evaluation tokens per second. We'll let this run just a bit, and I'll come back once this is scaled down and we can see this graph a little bit better. But you can see there, top speed in between them is about 23.6. Woo! Okay, so now that we can see it scaling down, remember this is during inference, not training. But inference of running the Llama 3.3 70B Instruct model at a Q8 quant across 6 A4500s, this is what your PCIe traffic looks like. So you can see the incoming and the outgoing traffic, RX and TX. We're averaging, it looks about 6.8, 6.7 evaluation tokens per second in this cluster. But as you guys can see, the PCIe traffic that is involved even in a multi-GPU setup once inference is going, not the loading of the model. The loading of the model, as you saw, it peaked way out, but is actually very low. This is actually one of the keys that makes distributed inference work, is because the traffic in between GPUs, you're only using high rate memory, and then the CPU is basically collecting it and spitting it back out at you. So what that means is don't overblow your PCIe traffic or needs when actually running inference across multi-GPUs. It's not nearly as much as what you probably thought it was. I hope this actually gave you guys some insight. Let's let this test run out and I'll show you guys the graphs of what Llama 3.3 looks like. I should point out that I'm not an expert at this. If you were doing multiple requests in parallel, running the model for multiple reasons and serving multiple requests to multiple people, this traffic would definitely be way different than this. But this will show you what's going on in your average home lab just doing average inference against your GPUs, or if you're doing a multi-GPU setup where it's actually going in between the GPUs and the CPU to do your inference. If you guys have learned something about this, because your consumer grade GPUs don't emit these metrics, but the enterprise level ones do, and the A4500s are considered an enterprise level card. Let me know what you learned. Let me know what you think about this. And as you can see, it's just going to repeat this pattern during this whole test of inference. If we go back and take a look, we're using about a total of 107 gigabytes worth of VRAM. You can see the GPUs themselves are bouncing in between, 0 to 20% across the board utilization. It's not all that much. The machine CPU, again, main thread is about 100% across one of the cores, and the rest of them are bouncing around 600-700% as it goes across the board. The GPU percentage is over here. Let's see where we're at. Test run number 5, still doing about 6.6 evaluation tokens per second. Let's go ahead and kick this test into fast forward. You guys can see that traffic down over there. Come back when it's finished. I'll show you guys the results of Llama 3.3 70B on a 6 A4500 GPU cluster. And again, it looks like we're averaging about, 6.5 tokens per second, which I would say is about average for the Llama models. The Llama 3.3 model is definitely a little bit verbose. It seems to be really good in my other testing for stuff that I've used it for, but I haven't had a whole lot of time with it yet, guys. 6.6 tokens per second. All right, let's run this test out and I'll show you guys the graph. Okay, again, finishing up at about 6.3 evaluation tokens per second. Let's go ahead and take a look at that report. I am just missing it. There it is. All right, let's expand this out a little bit so you guys can see a little bit better. This is the loading in the prompt evaluation time. It's milliseconds on the side. So that's why that graph is so far off. Let's go take a look at the evaluation times. Again, milliseconds. Total time going to be those basically put together. Prompt tokens evaluated, 111 across the board as normal. These are the completion tokens. This will mimic the length of your response, not the accuracy, but the length of your response in tokens. Total tokens put together, prompt tokens per second. We can see that it averaged out, it looks to be in between 250 and maybe just a little bit above that as far as the average goes. Prompt tokens per second. Now let's take a look at the evaluation tokens per second. As we saw, started off at about 6.8, fell down to about 6.3, didn't quite hit its plateau, but in average it was about just over 6 evaluation tokens per second. Let me know, guys, if you learned anything about the PCIe traffic that's going on behind the scenes, especially in a multi-GPU setup. Locally running Llama CP with LocalAI under the hood. If you like this type of stuff, just let me know below by hitting the like button. If you want to see more, hit subscribe, and I hope you guys check out some more of the videos and have some happy holidays. That was a terrible ending. Don't forget to buy your AI pizza. You have a time-traveling toaster that can only toast bread in the past or the future. You want to toast some bread for breakfast, but you don't know whether the toaster will toast the bread in the past or the future. If you toast the bread in the past, it will be stale by the time you eat it. If you toast the bread in the future, it will be burnt by the time you eat it. How can you use the toaster to get perfectly toasted bread for breakfast?